Good evening, Honors Algebra. Mr. Lawrence here with your flipped lesson for Monday, January 30th. Oh, this will be simple stuff, guys. Monday in class we worked on converting scientific notation. Today we're going to work on multiplying, dividing, adding, and subtracting. Now I know in class we did a little bit. We talked about multiplying really quick. And let me just say, what if you have a problem like this? Say 3x to the 5th times 4x to the 6th. Well, I think by now all of you understand that you need to do 3 times 4 and get 12. And then you need to do x to the 5th times x to the 6th. Well, that would be x to the 11th, right? This problem that I'm going to write up in blue is the same exact problem with different numbers. 3 times 10 to the 5th times 4 times 10 to the 6th. It's the same exact problem, only it's like the variable x has been replaced by a 10. Since it's the same thing, we're going to do it the same way. Yeah, we sure are. Now, I'm going to do 3 times 4, and I'm going to get 12. And then I'm going to do 10 to the 5th times 10 to the 6th. Well, how many 10s are being multiplied together? Well, there's 11. So that would be 10 to the 11th. Now, the only thing that's different is, remember, my answer needs to be in scientific notation. To have a number in scientific notation, it's going to be multiplied by some power of 10, which in this case it is. There's my 10 to the 11th power, so there's 11 10s being multiplied by this 12. But this number here needs to be less than or equal to 1, greater than or equal to 1 and less than 10, right? So it's got to be, the decimal point has to be after the first non-zero number. So let's take a look at this number, 12 times 10 to the 11th. Well, my decimal point, as I'm sure you know, is right here. I don't want it there. I want it here. Well, to move it there would mean I would need to divide by 10. Yeah, we're not just moving a decimal point, we're actually dividing by 10. All right, but if I divide this number by 10, I change the number, right? 20 divided by 10 isn't 20 anymore, it's 2. But what if I could divide by 10 on part of the number and then say multiply by 10 on another part of the number? Well, dividing a number by 10 and then multiplying by 10 would give me the same number, wouldn't it? Yeah. The only thing is, it's going to look different, but it'll be the same number mathematically. It'll have the same numeric value. All right, so I'm going to divide 12 by 10 and get 1.2, but then I multiply the 10 to the 11th by 10, and that becomes 10 to the 12th. Oh, so this number here and this number here are the same exact number. The only difference is this one is written in scientific notation by definition. All right? So you might have to convert your numbers to scientific notation. All right, let's see here. Let's try a division one really quick. Let's say I have 4.8 times 10 to the 5th, and that's going to be divided by, and I'm going to put this in a quantity, and that's going to be divided by 12 times 10 to the 2nd. All right, well, I know I have to divide here, and I know that 48 divided by 12 is 4, but 4.8 divided by 12 should be 4/10. All right, you can check me on that if you want. Now, I got to tell you, if you're always running a calculator to do this, these are going to be difficult problems. Please try to do them without calculators. Challenge yourself. The more you do it, the more you'll understand. And you're going to go, oh, it's easier with a calculator. It is now, but not for me, it's not. It takes me longer to do this problem on a calculator than it does to do it in my head. Why? Because I've practiced. And you guys are just as smart as I am. You can do it. You just have to want to, and that's the difference. And that's why some of you won't be going on in honors, because you refuse to make that transition over to an independent thinker, an independent learner. You want to be told the answers. Okay. All right, here we go. Here's my quotient after I divide, except I notice that my decimal point is in the wrong place. It needs to go here after the first non-zero number. Well, that would be like multiplying by 10. But if I just multiply by 10, I've changed the number. You know, zero point 0.4 times 10 is not 0.4 anymore, or 4 tenths. It's 40. But I don't want to change the number. I only want to change the way it looks, so it looks like it's in scientific notation. So over here, I'm going to divide by 10 to the first. Okay, so when I multiply, I end up with 4. And if you want to go, you can go 4.0 times 10, subtract my exponents, and I get 2. And there is my answer written in scientific notation. Okay. By the way, what would happen in a situation like this? Let's say you got 0.0, you just finished multiplying or dividing, and you got this answer. All right. Well, hopefully you realize this decimal point is in the wrong place. I needed to go 1, 2, 3, 4 places, which means I'm going to multiply by 10, or excuse me, yeah, 10,000. I sort of say that, right? Okay, where'd I get 10,000 from? Well, there's 4 Scoopies. 1, 2, 3, 4 zeros. But if I multiply that by 10,000, I'm going to have to divide it over here by 10,000. Well, 10 to the 4th. Isn't that the same thing? Right? So, in fact, if you want, you can just say, well, I'll multiply by 10 to the 4th power. Where's the 4 come from? 1, 2, 3, 4 Scoopies. Either way, they're the same thing. Okay, so now I multiply this, and I get 4.16 times 10 to the 3rd. And there you go. We're in scientific notation. Now, addition and subtraction is a little bit different. And let me digress for a moment here and say, you know that 3x plus 2y cannot be done. They're not like terms. You can't put them together. Okay? What you may not realize is that 3x squared plus 2x are also not like terms. They're not. Now, Quinn is saying to himself, no, Mr. Lawrence, they're both x's. No, Quinn, I disagree. I disagree. I think that this term here has 2 x's, but I think this term here has 3 x squareds. And x's and x squareds are not necessarily the same thing. Just like our 5's and 5 squareds the same thing. I'll tell you what, I'll pay you a job. You can come over and work at my house, and I'll either pay you $5 an hour or I'll pay you 5 squared dollars an hour. Well, only a fool would take the $5 an hour job, because the 5 squared dollars per hour is going to be $25 per hour. You're going to get 5 times the money. So they are not the same thing. They are not like terms. Okay? That would also mean that 16x to the 5th plus 3x cubed plus x squared, those are not like terms also. So you can't put them together. Now, when we look to add or subtract in scientific notation, we're going to come up to those situations. We're going to come up with a number that looks like this. How about 6.8 times 10 to the 5th, and we want to add 1.2 times 10 to the 4th. Now, some of you are going, oh, I'm going to add 6.8 and 1.2, and you're going to be wrong. You're going to be wrong, because check this out. This one is 10 to the 5th, but this one is 10 to the 4th. And remember earlier in the video I mentioned those are just like variables. They behave just like variables. They're not variables, but they behave like variables. We can't put them together as is because they're not like terms. But the cool thing is about scientific notation, we can make them like terms. For example, if this 4 was a 5, then I would have like terms. This 4 right here. If it was a 5, I'd have like terms. Well, I could multiply it by 10 to the 1st, and then that'll turn into 10 to the 5th. But that would change the rest of this number. So I'll have to divide this part here by 10 to the 1st. Okay, so I'm going to go ahead and do that. My left-hand number right now remains unchanged. Now, this number here, the second number, well, I divide 1.2 by 10, I get 12 100ths, 0.12, and then times 10 to the fifth. And look at this. Now they're like terms. Now I can go, oops, I lost my 5 there. Now I can go ahead and add 6.80 plus 0.12. Notice I'm very careful to line up my decimal points. Very careful. So 6.2, and now I just bring the 10 to the fifth down because I'm counting how many 10 to the fifths I have. I have 6 92 hundredths, 10 to the fifth. See how simple that is? Here, you try one. Subtraction works the same way, by the way. You just have to watch for carrying. How about I have 43.29 times 10 to the 11th plus 1.23 times 10 to the 12th. Okay, well, I'm going to want this guy here to become a 12. I could actually change this one to 11, but I'm going to change that one to 12. All right, so I'm going to have to multiply by 10 to the first, right? But if I multiply that part of the number by 10 to the first, I have to divide this part of the number by 10 to the first. Okay, so when I do that, I got 4.329 times 10 to the 12th plus 1.23 times 10 to the 12th. And look at that, things are lining up. Now they're both 10 to the 12th. So I can go 4.329, 1.23. I'll get a 9, I'll get a 5, I'll get another 5, and I get a 5. And that's 10 to the 12th. Now I always want to check and make sure my answer is in scientific notation, in which case it is. All right, this should be pretty simple. I don't want to take up any more of your time. I do want to stress that for multiplication and division, you can just go ahead and multiply or divide, just like you would with the variables, coefficients of variables. But with addition and subtraction, you have to make the powers on the tens match. Okay, you may want to go back and rewatch this part of the video to see what I'm doing, if this doesn't sound right to you. Again, try not to use the calculators or use them to check your work. Don't rely on them. Don't let them think for you. All right, Mr. Lawrence signing off.